The Hubble Space Telescope has been working in space for over 34 years. It has become one of the most important tools for scientists to understand the universe. Even though it was not meant to focus on the solar system, Hubble has captured amazing images of planets, moons, and stars. These photos have changed the way we think about space and opened up new questions about how everything works. Some planets in our solar system don't have their own dedicated space missions. That means many areas are still unexplored. But thanks to Hubble's sharp vision, scientists have been able to make discoveries without sending special spacecraft to each planet. This has saved both time and money while still offering valuable information. Hubble is too small to take a full picture of the Moon in one shot. The Moon is too large in the sky for Hubble's narrow field of view. So, missions like NASA's Lunar Reconnaissance Orbiter give us better and more detailed images of the Moon. This allows Hubble to focus on objects that are much farther away, like other planets, stars, and galaxies. In 2012, Hubble observed a very rare event. Venus passed directly in front of the Sun, an event known as a transit. Scientists used this opportunity to use the Moon as a mirror to observe how sunlight moved through Venus's atmosphere. This gave scientists clues about the chemical makeup of the planet's atmosphere. The method developed here is now used to study planets outside our solar system, called exoplanets. Exoplanet research has grown rapidly in the past decade, and Hubble has played a key role. It uses a technique called transmission spectroscopy. When a planet passes in front of its star, Hubble can measure how the starlight changes. This tells scientists what gases are in the planet's atmosphere. Hubble has detected water vapor, sodium, and even hints of organic molecules on distant exoplanets. Mars is another favorite target for Hubble's instruments. It has captured images showing the entire surface of Mars better than many orbiters around the planet. These photos show events like giant dust storms, clouds, and seasonal changes. This data is important when scientists are planning where to send rovers or landers. It even helps forecast weather on Mars before a mission launches. One of Hubble's famous images showed a dust storm covering the entire Martian surface. The planet looked like a smooth orange ball with almost no visible features. Hubble has also observed Mars's moon Phobos. This small moon orbits the planet in just 7.5 hours, making it one of the fastest moving moons in our solar system. Beyond Mars lies the asteroid belt, a region filled with millions of rocks of different sizes. Hubble has studied some of these asteroids, such as 6478 Gault. This asteroid has two long tails, like a comet. The tails form due to sunlight slowly changing how the asteroid spins. As it spins faster, material on the surface starts to fly off like dust from a spinning wheel. This process, called the Yarkovsky-O'Keefe-Radzievskii-Paddock (YORP) effect, is fascinating because it shows that sunlight can slowly change the shape and motion of space rocks. Some asteroids spin so fast that they almost break apart. Many are not solid rocks but rather loose piles of rubble held together by gravity. The asteroid belt is more chaotic than most people realize. There are over 1 million objects larger than 1 kilometer in size. Sometimes, these rocks crash into each other. One major example is the object P 2010A2. It was first thought to be a comet, but scientists later discovered it was debris from two asteroids colliding. The center of this object had an X shape, which is typical when fragments fly out in all directions. Jupiter, the largest planet in the solar system, plays a powerful role in this region. Its strong gravity pulls many of these objects out of their usual paths. Jupiter has often been called the vacuum cleaner of the solar system because of how it attracts or destroys potential threats to Earth and the other planets. One dramatic event that proved Jupiter's strength was the impact of comet Shoemaker-Levy 9 in 1994. The comet was torn apart by Jupiter's gravity and then slammed into the planet in pieces. Each impact released a massive fireball, hotter than 23,000 degrees Kelvin, rising over 3,000 kilometers above Jupiter's clouds. One of the strikes left a dark spot on the planet the size of Earth. Scientists calculated the energy released in that event. It was equal to 6 million megatons of TNT. This showed how Jupiter can absorb cosmic impacts that might otherwise hit Earth. Astronomer Eugene Shoemaker once said, "This is the first time humans have ever seen two worlds collide." That moment reminded us of the wild nature of space. Jupiter is also home to some of the most powerful auroras in the solar system. Unlike Earth's auroras, which come and go, Jupiter's are continuous and far more intense. In 2016, NASA's Juno spacecraft studied Jupiter from up close, while Hubble observed it from Earth's orbit. These combined observations revealed how solar winds and strong radiation belts power the auroras. Another mystery surrounding Jupiter is its moon Europa. Scientists believe that under its icy surface lies a huge ocean of liquid water. This ocean might be kept warm by the gravitational push and pull from Jupiter. Hubble helped discover plumes of water vapor coming out of Europa's surface, suggesting that there might be cracks in the ice through which water escapes into space. Even more fascinating, Hubble detected sodium chloride on Europa, the same kind of salt found in Earth's oceans. This discovery raises hopes that Europa's ocean might be similar to those on Earth, increasing the chances that it could host some form of life. Some scientists, like Dr. Robert Pappalardo from NASA's Jet Propulsion Laboratory, have said that Europa is one of the best places to look for life beyond Earth. After the Cassini spacecraft ended its mission in 2017, Saturn has no active missions observing it up close. That means Hubble now plays a key role in tracking Saturn's changes. It watches for giant storms in the atmosphere and how the planet's rings shift and change over time. Subscribe to our channel and thanks for watching.